All right. So we have already covered, the introduction part wherein we have uh, reviewed the products that are offered by PaloAlto networks. We have compared the legacy versus next generation firewall, where we saw what is statefulness, what is statelessness, and then we saw how the ACLs differ in legacy and NGFW, what is port tunneling or application tunneling, if you would like to call it. And then we also discussed about threat intelligence. So there were a lot of differences between legacy and NGFW firewalls that we covered over here. After that, we had a look at the PAN-OS architecture overview. In that, we discussed about single pass parallel processing architecture. I'm not going too deep into this part. Reason being, when we'll be discussing about life of a packet, you might not be able to see life of a packet mentioned over here in the syllabus, but I have a plan to cover that. But covering that in the beginning might not be a good idea because that will leave everyone confused, right? How because it's a huge flow. So we'll take it maybe in between, once we have covered like at least 5 or 6 modules, so that you have a fair understanding how the firewall works, right? And then it might be easier for you to understand the life of a packet, which is the entire flow, how the packet is received by the firewall, processed by the firewall, and then it exits the firewall, right? So in this PAN-OS architecture review, we have discussed about single pass parallel processing, wherein I gave you an idea what is single pass, wherein we don't have separate blades for each and every processing like URL filtering, or security policy checking or antivirus or anti-malware. So we don't have separate modules wherein the packet will be sent to each module for inspection, and then it might take a lot of time if you have separate modules, right? So I have shown you this diagram just for an example, wherein multipass, if there are multiple modules that would be there in a security device, it increases the latency and decreases the throughput of the device, right? So we have something called as single pass architecture, wherein app ID will do it in a single pass, content inspection will do it in a single pass, wherein all the pattern matching and everything would be done in just one go, so that we just have one content inspection engine. We don't have multiple components, right? And that content inspection engine is really powerful. So uh, that's it. I mean, this is what we discussed for single pass. Parallel processing is wherein we have like we call it as parallel processing because we have multiple DPs in a firewall. Now, when I say multiple DP architecture, it totally depends on the platform that you're using. However, as you move up the platforms, right? For example, if you go to like 1400 series firewall or 5200 series firewall, you'll see DP0, DP1, DP2, right? Multiple data plane CPUs that will be able to process the traffic parallelly. So that highly enhances the performance of your device. And again, security is already there in place, right? So this is what we have discussed so far in PAN-OS architecture overview. We also discussed about the licenses, like what all subscriptions are available or what all licenses are available that you can apply to a firewall so that that particular feature will be enabled. So these licenses are not like a blade wherein, for some of the vendors, you will see that they have a URL filtering blade wherein you have to go ahead and enable URL filtering separately. You just apply these licenses and these features will be enabled. Okay. You don't have to install anything physically on that platform to enable these features. It is already inbuilt on the PAN-OS. The license will enable that particular feature. Okay. We saw the licenses, right? We saw IoT security, which is for IoT devices. SD-WAN, which is again PAN-OS SD-WAN. There is a Prisma SD-WAN component, which is totally a part of Prisma. We are not covering that that is not in our scope, right, over here. threat prevention, and then we have advanced threat prevention. I told you that threat prevention is a legacy license. They are going away anyways. Advanced threat prevention, it has inline cloud analysis modules, and it takes advantages of machine learning to detect the threats, right? So that's the difference between threat prevention and advanced threat prevention. DNS security, which will inspect your DNS flows and queries. URL filtering and advanced URL filtering, again, the same difference. When we have inline cloud analysis, we use machine learning for, detecting the patterns and understanding the behavior. Uh, as the name says, URL filtering is to uh, you know, provide protection against URLs, malicious URLs, and categories based on you can have. We have certain categories which are predefined. We'll see all these in details as we go deeper into a course, right? As of now, I'm just providing you these information so that you are at least aware that there is such thing available on the firewall. Same concept with wildfire and advanced wildfire. Wildfire is legacy, and advanced wildfire is the one that you'll get now if you go ahead and purchase a license, right? Cortex Data Lake, we discussed even in the day one that we have a service called as CDL, which is a centralized cloud storage service where you can send all your logs and then it will be stored over there. It comes in like 1 TB format licenses, wherein if you want more storage, you can buy more number of license. So if you have 10 license, you'll be able to have 10 TB or terabytes of storage in Cortex Data Lake. Okay. Global Protect is a uh, license that you would use in case you have you know portals and gateways on different devices. You have Linux machines, you have Android machines that you'd like to protect. You'd like to do hip checks, that is your host information profile and all those things, right? So in that case, otherwise, if you're doing a simple RAVPN access where portal and gateway are on the same firewall, you actually don't need any kind of license over there for that. Okay. Uh, Fine. So Global Protect is their RAVPN solution, right? Virtual system, for those who might be aware about, Cisco firewalls, they might understand it's a context wherein you can partition a big chassis box or a big firewall into individual separate firewalls where each VSys will have their own security policies, and then we can also divide which interface will belong to which particular VCs, right? Based on that, it will act as individual firewall inside that big firewall. Okay. Uh, then we have enterprise DLP. DLP is like, in today's era, DLP is very crucial to protect your sensitive data. To now, this can come in both the models, like you have a physical boxes or on-prem solutions, on-prem firewalls where you can apply this license. At the same time, you have Prisma Access where you can enable this feature for SaaS application protection, right? So DLP is nothing but it's a data loss prevention feature wherein it can scan your traffic for sensitive data. It could be a social security number, credit card numbers. It could be your driver's license. Some countries have certain regulations like GDPR, HIPAA. So in compliance to that, some of the information cannot be leaked to the outside world, right? Because they have their confidentiality acts over there. So uh, these patterns can be detected using DLP, and then remediation actions could be taken based on that, right? And then we have something called as SaaS security inline. SaaS security inline is wherein, nowadays every application that you see is SaaS. Most of the applications are SaaS, wherein you go to a URL, then access their services. For example, Google Docs. You don't have to open a, uh, you know, Microsoft Word on your Windows machine. You just go to Google Doc and then you can create a document over there. So that's a SaaS application, right? So in order to protect all the SaaS application, because again, these SaaS applications also pose a security risk because we don't know what kind of data could be shared outside of the corporate network using these SaaS applications. So we need SaaS security inline to have protection for SaaS applications, right? In today's session, So this is what we have covered. I mean, form factors. I've given you a very brief overview about the physical VM, CN series, cloud, and GFW. VM series is the fire. I mean, these are the VM series firewalls are the firewalls that we are going to use in our lab because physical is not possible, right? And again, we saw there are series of firewalls like if you see 3200 series firewall, 5200 series firewall, 3400 series firewall, 5400 series firewall, and then 7K chassis boxes. And then there are smaller boxes which are PA 220, 820, 850, 450, 440, right? These are like smaller boxes. So these were physical VM series. We discussed about VM50, VM100, 300, 500, and 700, right? Now, VM700 is a very the highest model that was available in the VM. Down the line, these models are also gonna get changed because uh, Palo Alto is introducing something called as a flex licensing model, right? Wherein you will be able to decide how many CPUs you would like to allocate to management plane and data plane, right? But again, that is not a really big concern as of now. We are not gonna dwell deeper into that. Uh, Cloud NGFW, I explained it to you. It's nothing, it's similar. It's a virtual machine, but it's a cloud native solution. It resides there. AWS is going to take care of the storage, the physical platform, whatever is needed, right? So you just need to deploy. For example, you install a software on your laptop, you just do next, it's installed, and then you use it. As simple as that. You're going to go to a AWS, you're going to deploy the solution without being worrying about what is the best size of virtual machine that you would need, to spin this cloud NGFW. So that was a brief about cloud NGFW, right? So the module one is completed. In today's session, module two. Before jumping into module two, we have to look at something called as overview of day one config, right? Now, module two essentially covers your deployment mode, PAN-OS upgrade, and dynamic updates. Now, deployment modes like uh, layer 3 deployment, layer 2 deployment, vWire, and tab deployment modes. These are the four deployment modes that are available to us while we are using Palo Alto, right? And then we'll see how you can upgrade the PAN-OS of the firewall, what is the preferred release, how you can check all that information, right? And then how you can do the dynamic updates, why we do dynamic updates, and what are the best practices that is recommended by the Palo Alto. Now, this is in module 2, but we cannot jump directly to module 2 because before jumping into module 2, I need to introduce you to the firewall, how you can, have a GUI access of the firewall, how you can configure the management access, and the basic day one config, right? The day one config is nothing wherein everything is just we bring the firewall to a functional state with the minimal configuration. That is what is called as day one config. So what we'll do today, we'll start with the overview of day one config. Okay, we'll uh, see how you can go ahead and configure your management access for the firewall, management interface for the firewall, and then how you can access the GUI of the firewall, and then how the configuration and everything looks like. And then once we are talking about the interfaces, I'll go ahead and explain, and even we'll do the labs for L3, L2, vWire, and tap modes. However, in 90% of the deployments, you will see the firewall will be deployed in layer 3 mode, okay, wherein firewall will work along with your routers, and it will participate in the routing as well, okay. Layer 2 is not very common, but I have seen few deployments for layer 2. Yeah, vWire is common. I have seen vWires wherein, for example, you would like to introduce a firewall in your environment. So you don't want to make immediate changes, right? So what we do, we deploy it in vWire mode, wherein it's sort of like a bump in the wire, wherein it is not taking any participation in layer 3 routing or layer 2 switching or any such thing. It's just the packet is coming on one interface and leaving to the other interface while we are subjecting that particular packet to all the security policies and inspection. Okay. And tab deployment mode is nothing wherein, you, uh, those who are aware of Cisco, they might have worked for port, they might have worked on port mirroring, right? Wherein they mirror a port and then send that particular traffic to Palo Alto, wherein we do the security inspection on that traffic and then we drop the packet. That's it, because it's a copy of that original traffic, right? Why we do that? That is wherein, when you'd like to just see how efficient is your existing security solution and what is the visibility that you get if you deploy Palo Alto solution, right? So, but again, don't worry about all these. I'll show you this in the lab. Today, let's go ahead with overview of day one config. Now, before I jump into overview of day one configuration, there are a few things that I need to, uh, you know, explain to you before you get into that. So the first thing is management plane versus data plane, right? So what is management plane and what is data plane? We need to understand this, uh, so that it will make our lives easier when we jump into the actual configuration of the firewall, right? Now, if you see a firewall, right? If you see a physical firewall for that matter, virtual you cannot see, right? Obviously. So physical firewall will have few interfaces that will be like, you'll have a management interface, you will have a console interface, and then you will have certain interfaces. I'll show you the front panel view as well in a minute. Okay. So these will be your like Ethernet 1/1, right? So, and then this will be maybe 1, 2, 3, 4, 5, 6, 1/6, right? So these will be your Ethernet interfaces. Okay. Like you do for a Cisco box, you connect to the, you can, when you're booting the router for the first time, you can take the console access of the router and then you can, configure the firewall. Similarly, we do it over here. You can connect the console cable or you can connect a management cable. I mean, you can connect to the management port, right? So the cable is, if it has RJ45, then RJ45, you can have a micro USB cable as well that can get connected depending on the model, what port is available, right? So you can take access to the, you can connect to the management port or the console port, and then we can start configuring the box, right? Now, in order for able to access the management port, the first and foremost important point over there is to have an IP address assigned so that you will be able to access that port, right? So management interface by default, the default IP address that firewall has is 192.168.1.1. Okay, that will be your default IP address that will be assigned to this management interface. And then once you have the access, you'll be able to, sort of like maybe change the IP address, right? Uh, so what you do, you take a management cable, connect it to the management interface, connect it to your laptop, and then you do an SSH to this IP address 192.168.1.1, and then you can go ahead and configure the IP address that you desire, and then you can do a commit. Okay, I'll also talk about commit, how or why we need that, but that will be later, for a later time. Okay. So this is the default IP address. The default credential will be admin, right? So this will be your username and this will be your password. Okay. So once you are able to log in to the firewall, it will ask you or it will prompt you to change the password first. And once you have changed the password, you'll be able to log in inside the firewall. Now, you see this management interface and the console interface, or whatever the management ports you'll be seeing, this runs in a separate plane. We call it as management plane. Now, why we call it as a management plane is because it has its own CPU. It's having a dedicated CPU for the management task. Okay, and the interfaces that you see over here, like Ethernet 1/1 or whatever, data plane interfaces. Uh, these are part of your data plane, right? Data plane interfaces. So this actually takes care of your traffic that you are that you like to get inspected on the firewall. So the actual data or the traffic which is traversing in your environment will be traversing through these Ethernet interfaces. Now, as of now, I am saying Ethernet. It could be an optical interface as well. It could be, I mean, wherein you plug in an SFP and have those ports, right? Optical fiber channels, right? It could be that, or it could be any other medium. But the most significant part is this is a data plane interface wherein all the data in your environment, wherein you put this firewall in line, will be traversing through your data plane interface, and that traffic never goes to your management plane. The management plane will never look into your data plane traffic. Okay. uh, the management plane will have its own CPU, and the data plane will have its own CPU. Okay, and they work independently. Now you would say, why do we have this separation, right? This separation is so that, for example, your the firewall is uh, facing I mean, a very heavy load of traffic is going through your data plane. Okay, and if, let's say, there is no segregation between data plane and management plane, that is, your same CPU is helping you with your management access as well, or other management task as well, you will not be able to access the device seamlessly, right? You will face challenges accessing the device or configuring the device or making any changes to the device if there is if the device is severely loaded, or even it might crash, right? So even if your data plane crashes, uh, if I mean, I would not say crashes, but if there is something that is not right, even with your data plane, your management plane is still accessible, and you will be able to do certain configuration or the troubleshooting that would be needed, right? So that's why we have, or that's why the data plane and the management plane are segregated. Data plane has responsibilities, or the task which is related to the traffic, the actual traffic, and management plane has the task which is related to the management of that particular device. Now you will say, what kind of task? For example, accessing the GUI, displaying the logs, or forwarding the logs to an external server, right? And then there will be like a few other daemons. It will check for the configuration, push to firewall, right? Now, I'll say firewall. I'll introduce daemons as well, but I don't want to use all the jargons as of now. Configuration, whatever configuration you are doing, there are certain processes that run on the management plane. The management server is one of the process, and that management server is gonna reach out to all the other processes and see if they are okay with this configuration. And once everything is okay, your configuration will be committed on the firewall, right? Now, every configuration that you see on the firewall, like security policy and security profiles, that is then pushed to your data plane, and then based on those policies that is received by the data plane will be able to process your traffic. That is, it will do the inspection. It will check if there is anything malicious or anything that is allowed or denied based on the actions that you configure, and then it will allow or deny the traffic, or drop the traffic, whatever configuration that you have done. Okay. So this is about basics of management plane, data plane. I'll talk more about it when we go into the configuration, when I'll show you individual things, right? We'll discuss this as we progress. Any question related to management plane or data plane, guys? There are processes that run over here. They are called as daemon or demons, whatever you'd like to call them. I'll show you those demons on the CLI, but right now is not the right time. I'll just so you know that demons are it is similar to that you see on the Linux, right? So Linux has a daemon for a particular process or a task, right? Similarly, we have because it is based on CentOS, you will be able to see demons over here as well. So just for example, like management server is a daemon wherein it will the responsibility of it is like the this thing GUI and log forwarding and all that. So then there is a route daemon that takes care of all the routing part, dynamic routing, and establishing the neighborship, BGP peering, and all that. So we'll talk about that, but this is just a surface level introduction about management plane versus data plane. Cool. If you guys do not have any questions, let's move to our lab part. Cool. So this is the basic lab that I have created as of now. This is similar topology that we have seen in our boot camp as well. This is good enough for introducing or getting an idea how you can do a day one config. Okay, so you can see right now this is a PaloAlto firewall. Let me go ahead and show you. This is the image that we are using, right? PaloAlto 11 we should be using. I'll change that. So I'll show you the Panos version once the device is booted up, and 8 gig RAM with 4 interfaces. We are not using a lot of interfaces on this device because uh, we don't need it, right? As simple as that. You can, Salman Khan. Is there any question, Salman? Okay. All right, cool. So we don't need it, right? So that's the reason we are not adding more interfaces over here. And let me save this. Let me go ahead and start this firewall first. Right. It will take up to 4 or 5 minutes before this firewall gets booted. Sometimes it might take 10 minutes as well. So you will have to be patient, and even this happens in the production environment based on the model. If it's a PA220, it takes a lot of amount of time, right? Because it's a small box. So generally, I get requests like, we booted the firewall, we are not able to log in. Which one is the stable version, PAN 10 or 11? I'll show you that, Salman, in a minute, how you can how you can differentiate between the preferred release and, what are the recommendations. I'll show you that in a minute, right? All right. So generally, when the device boots up, there are few processes that run at the back end that needs to be completed in order for it to be successfully booting it up, and then you'll be able to log into the firewall, right? Now there is a process called this is called as auto commit, right? When the device boots up for the first time, there will be a process that runs that is called as auto commit. That auto commit is nothing, it's just committing all the configuration on the firewall so that it is available for your disposal. Once the auto commit process is completed, you will be able to log into the firewall. It might take some time depending on the firewall model, the memory that it has, and all those things. So we can see it's still booting up. Meanwhile, this is booting up. I'll explain you the topology that I have over here. Okay. You can see. the management network, right? This is out of band management PC. Let me explain it in whiteboard. That makes it easier. How many maximum ports available in the hardware firewall to the latest? See, it depends on the platform. I don't remember the exact count, but it varies. It deeply varies. And again, there are certain ports wherein one port can be, divided into four ports as well. So it depends on the models. Then again, now when you go towards your 7K chassis boxes, you can it's a modular concept wherein you have a network processing card and you can apply up to, I guess, four network processing cards, and those network processing cards each will have, I guess, 8 or 12 interfaces, and based on that, up to four interfaces can be plugged, four NPC modules can be plugged in. But I'll show you that in a minute, wherein we'll see the front panel of the firewall. I'll show you how you can find what particular model has how many interfaces and how you can connect to it. Okay. So the lab topology is like we have our firewall, we have the management PC available over here. Okay. This management PC, the job of this is to access the firewall, and we have connected it to the management interface of the firewall. Okay. So what you can do, whatever IP you configure on the firewall interface, that is the management interface, this management PC should be in the same subnet, so that we'll be able to access the management IP address of this firewall, and then we'll be able to get the access of GUI and make our configuration changes from this management PC, and then commit the changes to the firewall. Okay. Onto the left side, we have LAN environment, that is your local area network, where all your client machines would be present, right? So we have like two Windows machine. We then have a switch, and then that switch is connected to the firewall. This interface is going to act as a default gateway for these machines, right? And the traffic is going to flow from this machine towards firewall. And then we have an ISP router, and then we have internet, right? We have named this as a LAN zone, or you can call it as a trust, because this is our internal environment. I'll give you explanation about what zones as well. Do not worry about it as of now. But this generally we have named it as a trust zone. You can call it anything you like, as long as there's a difference between all the zones that you are using in an environment. Okay. And we call this as untrust zone, right? So this interface is connected to ISP, and we call this as untrust zone or untrust WAN, whatever you'd like to call. This is just for your understanding, where this has connectivity towards internet, and this one is your internal network LAN. Okay. So this is the topology that we are using. Let's see. All right, cool. Now you can see VM login is being displayed for the Palo Alto firewall. Let's see if I'm able to log in or not. Admin, admin. This is the default credential. You see login incorrect. I told you when the firewall boots up, there is a process that goes on, that is auto commit. We need to wait for that to finish. You can see the prompt changed, PASDF login, but the login incorrect message was displayed, right? Let's try it once again. Nope, still not working. So that means we have to wait for some more time, maybe like a couple of more minutes, and then we'll try again. Okay. In the meantime, this is booting up. Let me show you the front panels. Okay. So PA, let's say 1400 front panel. So this is how your firewall will look for 1400, right? Whatever model you have, if you'd like to, have you'd like to check how many interfaces are there, which interfaces are supported, and all those, you can type that model name and then type front panel. Okay. Series front panel, and you'll get the link. You'll be able to open that. Okay. So you can see these. I'm not sure if it is visible. So These ports over here, right, till 12, these are your Ethernet ports, then these are your SFP ports, then these are again some ports where management on console can be plugged. Uh, you can see there is a USB port, micro USB port, and then there are LED indicators. Okay, let's have a quick look. Ethernet 1 through 12. These are 12 RJ45 ports for network traffic or the data plane interfaces that we discussed, right? You can see from port 1 through 8, it can support up to 1 gig. From port 9 to 12, it can support up to 5 gigs, right? So if you need lower bandwidth, you can connect to anything between port 1 to 8. If you need higher bandwidth, then connect to port 9 through 12. Similar kind of setup will be there for 1420. Now, this is 1400 series, wherein 1410, 1420 will have a similar look and number of interfaces. But guys, just give me a second. I'll be back in a minute. All right, guys, I'm back. Sorry for that. So these are the ports which are Ethernet ports, and that will carry your network traffic or the data plane traffic. Okay. Then you can see port 13 through 22. These are SFP plus port, right? So 10 SFP or SFP plus ports based on the installed transceivers, right? So transceivers are used for connecting to your optical cables. Uh, SFP mode will have 1 gig output and SFP plus will have 10 gig output. Again, port 13 to 18, 1 gig for 1410. And then 19 to 22 will have either 1 gig or 10 gig based on the SFP that you're using. Similarly, this changes a bit for 1420. Port 15 to 22 are like 1 gig or 10 gig port, right? Then we have HSCI port. This is used for HA configuration. Then you have a dedicated HA1 port. This is again used for your high availability configuration. We have management port. So port 5, this is your management port. This one is your management, right? And then you have a console port, which is RJ45 that I told you about. Then you have USB port. This could be used as a flash drive for bootstrapping, right? And then you have again a console port, which is in micro USB format. Now you have a choice, right? You can use either a micro USB cable to connect. You can use a USB, you can use a RJ45 cable to connect to the console, or you can connect to the management port provided the IP address is configured. So this is how you can verify your front panel, how it looks and how many ports it has. It could be different for different platforms. If I show you PA 7080 front panel, it would be way different. So there is no, you can see this looks, this is your 7080, and then it will have SMCs, right? So SMC and then NPC and then DPC, right? So this is your NPC. So these will have different slots, and based on that, the number of interfaces can vary depending on how many NPCs you are using or DPCs you are using. Okay, cool. Let's get back to our firewall business. Let's see if we are able to log in now. Great. We are able to log in. It's asking for old password. Admin And then new password, I am setting as test at 123. Cool. So let me write it down over here. New password, test at 123. Okay. You can, if you're doing your labs, you can keep it anything you like. I'll also show you the access of lab, but as of now, let's go with the flow first. Okay. Uh, cool. We are able to log into the firewall. We have changed the password. The first time you will log in, it will ask you to change your password. Okay. Now, you can see I would like to access this firewall through the management PC. And I told you that you cannot do that unless you have an IP address assigned to the management interface. There is a command that you can run to check what is the IP address that is being assigned to the management interface right now. Show system info. Don't worry about the commands. You can always watch the video again, and I'll share these across. Okay. Show system info. You can see IP address is unknown. Why? Because this is a VM model. If you see any physical models, you will get that default IP address of 192.168.1.1. Okay. Now, if because the IP address is unknown, can we access this firewall through the management interface? No, obviously no, right? So the first thing would be to configure the IP address for the management interface. Okay. Let's go ahead and do that. Don't worry about rest of the information. We'll check that. Uh, so similar to what you have in Cisco, we have a configure mode in Palo Alto for making any configuration changes. You need to go to the configure mode. We need to provide now these commands again. I'll share it across. Set device config system IP address, then IP, that is my 192.168.1.1, then mask, sorry, net mask, that will be 255. Sorry, my numlock was off. Set device config system IP address 192.168.1.1, net mask 255, 255, 255.0. That's a /24. And that's it. I'll hit enter. Okay. Now let's check if it is there, right? Show system info. If you'll see, it is still saying unknown, but I just entered that command in front of you. So isn't it supposed to assign the IP address to the management interface? So that is true, wherein that configuration is present in the candidate configuration. We'll see how that candidate configuration differs once we are able to log into the firewall. So this is where I'd like to tell you the concept of candidate configuration and running configuration. So generally on a firewall, on PA firewall, you'll see there are two types of configurations. One is candidate configuration, and then running configuration. Okay. Now, candidate configuration means the configuration, whatever changes you are doing will be in the candidate configuration. Okay. That means it is not yet applied to the firewall. It is there. We need to make a commit request, or we need to do a commit on the firewall so that that particular configuration moves to your running configuration, right? So running configuration is the configuration which is already applied to the firewall, which is in action, which is, all those things are applied to the firewall. Candidate configuration is the configuration that you would like to apply to the firewall, that you would like to, that you would like to commit to the firewall. Okay. So whatever changes you do will always go to the candidate configuration. You need to do a commit in order for those configuration to go to the running configuration, and then that configuration will be applied to the firewall. Okay. So that means what? I need to do a commit over here. So configure and then do a commit. Now, again, there's one more thing. By default, the mode is DHCP. Okay. So we need to change that as well. If you see IP assignment is DHCP, I have assigned an IP address, but I have not changed the mode of it to static. That will again cause a problem. So we need to change it to set device config system type static. Right now, these are the two commands that you need to uh, enter in order for the changes, in order for the configuration of your management interface. Okay. Now let's go ahead and do the commit. Every time you commit, there will be a job that will be scheduled. Those who are coming from a Linux background, they might be able to understand this terminology. Even if you do not understand it, do not worry. This is, you'll get a hang of it as we do it, down the line, right? So don't worry if you feel like, some of the things are a jargon for you. That's all right. It happens for the first time. Okay. So job is nothing wherein that particular job is being moved from candidate configuration to the running configuration. That configuration is applied to all the daemons which are present on the firewall. And once this commit job is successful, your configuration would be applied. Let's see that. You can see it's 98% completed. For local PA box, we don't need both commit and push. No, Shrikant. Push is generally when you have a panorama, you're configuring any changes on the panorama and then you're pushing to the firewall. Then we do a commit on the panorama and then do a push to the firewall. Right. Looks like this change got committed. Let's see. Let's validate. Show system info. We can see now the IP address 192.168.1.1 is applied to the management interface and the net mask is 255.255.0. We are not assigning any default gateway because we are not doing any routing for the management traffic as of now. The management PC is going to be directly connected in the same subnet with the management interface, right? So we don't need a default gateway. You can do that in a production environment, provided you are doing the routing for the management traffic. Okay. And the IP assignment is static. That is, we have statically configured this. Okay. If you would like you to receive this IP address from a DHCP server, you can configure it as DHCP. The best practice would be to have it statically configured because DHCP sometimes might cause an issue wherein the lease time might have expired and your DHCP server might not be reachable. Then that might create a problem at times. Okay. Cool. So now we have an IP address configured to the management interface. In order to access the GUI of this firewall, let's go ahead and configure let's go ahead and start this Windows machine. The password for Windows machine is welcome. All these credentials are mentioned over here. Windows machine password is welcome. The PaloAlto's default password is admin, and then you can keep the new password as test12 @123. You need a capital letter. It should be 8 characters minimum, and then it needs a special character, and then it needs a numerical. If you meet all these requirements, your password change will be successful. I've seen people, uh, not able to change this password because they don't meet this criteria, and then they are banging their head as to we are not able to change the password, right? So there's a criteria, or else just use this password. That is simple, right? We are doing a lab. That's it. So let's see what is the IP address right now for this machine. So there's no IP address right now. Let's go ahead and configure that. 192.168.1.2. So it is in the same subnet. 255, 255, 255.0. I'm not going to assign any default gateways over here. And we don't need DNS, to be honest, because we are going to access this management IP address using the IP address directly, right? Let's click on OK, close, close. Okay. Now let's go ahead and try to access the management or the GUI of the firewall. HTTPS 192.168.1.1. You'll get this. Your connection is not private because this firewall is just booted up. There is no server certificate that we have installed on this firewall. We'll see how that we can do in like when we reach mid of the course. Uh, this is again where the certificate management part comes into the picture. Okay, you have to click on advanced, proceed. Just one disclaimer: if you are using a new Chrome, let's say you are working in your production environment and you have a new version of Chrome, and then you'll get this warning, but there won't be an option to proceed, right? Then you can just type "this is unsafe," and then it will take you to the page. Okay, so this is like some security feature wherein they don't like you to visit websites for which the certificate is already expired or not present. Okay, cool. Admin, then the password that we have changed, test at 123. Okay, so this is how your uh, GUI will look. Okay, uh, so if you see the device name or the host name right now is PAVM, management IP address that we have configured, and the subnet mask, you'll be able to see the model that is it's a VM, right? PAVM. Serial is unknown because there's no license supplied as of now. This is CPU ID, UUID. This is related to the virtualization, and sometimes you might need this for applying the license or maybe moving the license to a different VM. Currently, VM cores, it has two core that is being allocated over here, 8 gig of memory that we have allocated. VM license, none. Uh, and the software version. We have 11.0.1, that is the PanOS 11.01. Now, the good thing about PanOS 11.01 or 11.0 is that you don't need a license for viewing the traffic logs, right? So, even if you like to set up a lab in your uh, laptop, you can do that, right? You can have a GNS or any such thing. You can spin up using an OR file, and then you can have this version wherein you can simulate the traffic and you'll still be able to view the logs, right? Mm. Post time, is it mandatory that we need to log in with management port to set an IP address, or it can be done in GUI also, or this GUI accessible only after created IP, which is okay. So, Praveen, good question. See, understand the flow. Because this was VM, there was no default IP address present. On the physical boxes, the management interface will have a default IP address of 192.168.1.1. Now, because it has a default IP address, you can access that physical box while connecting to the management port, and then you can do the configuration from the GUI if you'd like. Okay. Because there was no IP address assigned in our case, because it's a VM firewall, we have to go ahead and access that. Now, this when I click on this firewall, right? This opens this console. So this is as good as connecting to the console port or console cable to the firewall. Okay, this is not an SSH connection that you are able to see the CLI. This is the console connection. Okay, that is why we were able to see when the firewall was booting up, all those process and everything was visible to us. Okay, for the management interface, you will not be able to access the management interface until the device has completely booted up. That is the difference between the console and the management. So sometimes you need to boot into maintenance mode, wherein you need to do some troubleshooting. That is not possible through the management interface. So that is why we use console port. Okay, so to answer your question, you can, depending if it is a physical box. Cool, great. All right, so we can see now the GUI. This is the general information that you would be able to get here. You'll be able to see the logged in admins. You can see admin console, right? It says console because I am logged in over here as using a console access. It is not a physical box, it does not have a console port, but this access is console access. Okay. Then I have logged in again using the same credentials to the web GUI of this firewall using the IP address of 192.168.1.2. That is my Windows machine IP address, right? So when I have logged in, all these audit logs are available over here. For how much time I was idle, these information, right? These are system logs. These are useful in troubleshooting your system related issues, or if you'd like to see what's actually going on, right? Uh, you have system resources displayed over here. Now, this is a license which this is a VM which is not licensed, but still you can see that it supports good amount of 5 lakh session counts because this is the PAN-OS 11.0, and you'll be able to see the management CPU and data plane CPU over here. Now, I hope that it might be you might be able to imagine why the DP CPU and MP CPU is different, right? So the management CPU is at 26%, but if you see data plane CPU is at 0%, because the management task is separated and the management task is taken care by your management CPU, right? But as of now, there is no actual data traffic that is going through your firewall. Okay, let's refresh this. Uh, you can see management CPU is at 2%, DP CPU is at 0%, and this session count is with respect to the data traffic or the actual data plane traffic that will be traversing your firewall. So number of sessions that it can have. And I've already told you guys, a session is like a combination of C2S and S2C flows, right? Wherein a session will be installed on the firewall. Okay, good. These are the things that you'll be able to see on the dashboards. If you again, these are config logs. We'll talk about that later. Okay. Uh, if you'd like to add any other information, you have the widgets over here. You can select these widgets and you'll be able to add that information. For example, if I talk about high availability, if I select on high availability, you see there's one widget that is added, and it says HA not enabled because we have not configured high availability for this particular firewall as of now, right? These are movable. If you'd like to move it here, you can do that, right? If you'd like to remove that, that should be okay as well. So this is about the dashboard. You'll be able to see your admin over here. Then you see logout, right? When you can log out from this uh, VM or firewall. You see task over here. This task will give you the information about all the jobs that we're running. So auto commit, this is when the firewall first boots up. That's what I was telling you about. This has to be successful in order for you to be able to log into the firewall, or in order for you to able to access the firewall. Okay. Without this, it might be difficult, and then we might have to do some troubleshooting, right? Commit is the commit job that I have triggered when I have assigned the IP address to this firewall. Okay, great. So management access configuration is done. We are able to access the firewall. Now let me show you that I can also do an SSH to that firewall. So this was the web GUI access, right? Let's see if we are able to do an SSH or not. So let's open our putty. 192.168.1.1 and open. First time it will prompt you for the server source key is not in cache. You can just click on yes. Admin test at 123, and that's it. We are now logged in on the firewall using the SSH. This is the console access. This is the SSH access. This is the web GUI access. This is how you will be able to access your firewall. Right now, you can see this is CLI. It does not say console, right? So we are accessing using the SSH protocol. All right. Any questions, guys, so far? Anything that might be challenging? Anything you'd like me to explain it again? Uh, Feel free to raise your hands or you can just drop me a message. Okay. No messages, no hands raised. So I will take that as that you guys were able to understand the management interface configuration for the management access of the firewall. I told you there are three ways we can access the firewall. One is the console access, other one is the web GUI access, and the SSH access, right? Management access and SSH access will only, or the web GUI access and the SSH access will only work when the IP address has been configured on the firewall. Cool. So if we forget the password of firewall, how do we recover? So if it is being managed by Panorama, it is easy. But if you forget the password, then there's actually nothing that you can do. You might have to reset the firewall because that is, the breach of sort of like there might be when you can log into the maintenance mode and you might try to log into the previous saved config. That might be helpful if you remember the password, but again, uh, there is no other way. So the best way is like if it is managed by Panorama, you can configure a new administrator and then push, or you can change the password and then push the changes to the firewall. But if it is a standalone, then there's no other way to go, right? You'll have to reset the firewall to the factory settings, and if you have the configuration backup, you can load it up. Okay. Mm. Yeah, Ganesh, you can speak. I have unmuted you.
Yeah, hello. Management, I'll just tell my understanding. So management, we need the IP address to, let's say, change the IP address or do configuration. Let's say we don't know the uh, password, so cannot change the IP address anyway, so no access. But console is like you will use the putty, right? So will that still require password or IP address? IP
Yes.
address anyway not required in the console, right?
The console does not need IP address because this is where this is the console access, right? So console will not need any uh, uh, IP address. I'll just simply click on this and you'll be able to see the console access, right? But if you have to take the management access, right? For example, the web GUI using the management interface. Right now, this machine is connected to the management interface, right? So we took the console access, assigned the IP addresses, and once the IP address was assigned to the management, we were able to access that firewall from our machine using the management interface, right? So we took the console access to assign the IP address first, and then once it was assigned, we took the management interface access to the management machine.
Okay, so there is no way, like if I don't know the password of the management plane, I can get some additional, access via the console. Let's say
Nothing.
first
See, again,
use.
even if you take console access, right, you will have to log into the firewall, correct?
Okay.
You cannot log into the firewall, then you cannot make any changes. So this is where the security comes in. This is where administrator has to be responsible. If there is a password expiry that has been configured, they need to take a note of that and make sure that the passwords are changed. However, as I mentioned, if this firewall is managed from Panorama, there is a way wherein you can configure a new administrator or maybe change the password of the existing administrator and then push it to the firewall, and then you'll be able to log in with that new credential. Okay.
So what is that panorama thing? Not getting exactly panorama.
We'll get into that. Panorama is a
Okay.
central management solution, right? We'll discuss about it towards the end of the course. That is,
Centralizing, is it like something centralizing?
yes, it is a centralized management server wherein you can manage the configuration of all of your firewalls in one place, right?
Thanks, thanks.
All right. Cool. Mm. In Cisco, we do have password break procedure for route and switches. See, Cisco is a routing appliance, or that's still okay, right? But if imagine you have an Apple phone and you are able to crack that password, what will be the credibility of that Apple device, right? Anyone can do a crack, then there is no security in that. So that is the whole point of this firewall. We are a security platform. We can't do that even if we want to do that, right? So that is where you need to be responsible and able to understand that this is important, right? So that's how it works. Cool. Where we can download backup of the firewall configuration like a file. Yes, Praveen, we'll see that, Praveen. I'll show you. What is the difference between normal configuration and panorama configuration? See, again, we'll talk about these during Panorama, but for your understanding, Panorama configuration, Panorama will have like device groups and template stacks wherein you'll be able to configure all the configurations which is present on your firewall from Panorama. And once it is configured, you will be doing a commit and then doing a push on the firewall. Now, once everything is managed by the Panorama, you won't be able to edit those policies simply, right? Those are managed by Panorama. You can do certain overrides, but it might not be feasible for you to do that always, right? Cool. So Panorama is a central management server where you can configure like hundreds of firewall and then push the changes to all the firewalls at one go. Cool. So let's go ahead and configure again day one config we were talking about, right? Management access being set up. I will configure a simple setup right now without giving much of information so that we are able to at least cover the topics that we have decided today. That is overview of day one config, right? So let me go ahead and let me start this Windows machine and we'll allow it to start. In the meantime, let's go ahead and configure a basic security policy or allow any security policy, right? So before doing that, we need to configure our interfaces, right? Uh, this interface Ethernet 1/3 is connected to your LAN environment. This interface Ethernet 1/1 is connected to your WAN interface. Let me start this as well. All right. So what we are going to do, we are going to assign IP addresses to this Ethernet 1/3 interface and Ethernet 1/1 interface. You guys, when you will be doing your lab, you don't need to touch this WAN part. This is automatically configured for you. You will be doing whatever changes on the trust and the management and the firewall side, right? This is ideally, I mean, this is already configured. You don't need to touch it. And even in the production environment, right, ISP is taken care, the ISP router will be managed by the ISP itself. So you don't have to go ahead and touch those ISP routers. Okay. So Ethernet 1/3. Let's do one thing. No worries, Manoj. You're welcome. Uh, let's assign a subnet of like 172.16.1.0/24. We'll assign a subnet over here. And then let's give 10.10.10.10 or 1 second. One second, guys. I'll have to format. Sorry, guys, I actually messed up with my config. I was playing around with this. Give me a minute. Cool. No worries. Let this download. We'll come to the router part. I'll show you that config later on. Actually, I was playing around, so I sort of like messed up the default app configuration on the Windows machine. Anyways, so let's assign the IP address to Ethernet 1/3 and 1/1. In order for assigning the IP addresses, we'll come down to the network interface, right? We have connected 1/3 towards our LAN. Let's go ahead and assign an IP address of 172.16.1.1 because this will be the default gateway for this Windows machine. Okay. So 1/3, we'll click on this. We will configure this as a layer 3 interface. Now, this is the reason I said until we see this once, we'll not go ahead and discuss the deployment modes. We'll see how this layer 3, layer 2. Right now, we are deploying it in layer 3 mode. Okay. So interface type is layer 3. We will have to assign it to a virtual router default, and then we need to assign a security zone. We have not created any zone, so I'll show you how we can create that. As of now, I'm just assigning the virtual router as default. This virtual router default is already present in the firewall. Okay, it does. I mean, you can create a new VR if you want, but there will be a default VR which is already present. Okay, let's go ahead and assign the IP address. This has to be static IP address. We are not configuring this interface as a DHCP client, right? So static. The IP address is 172.16.1.1/24. Enter. And then we, by default, all the traffic coming to your firewall is denied. Okay. I mean, I'm talking, for example, if you'd like to ping 172.16.1.1 from that Windows machine, if you'd like to ping from this Windows machine to this interface, that ping, you'll not get a reply. That ping will be dropped. This is the security feature of firewall. Every traffic towards the firewall itself will be denied by default. Okay. So, but we want to test, right? We are able to reach 1/3 or not. So we need to explicitly enable something called as interface management profile that will allow the ping for this particular interface, right? Let's go ahead and configure the interface. So you see this management profile over here. We are going to click on the drop down. We're going to configure a new management profile. Wherever you see this new, you have an option to click on that and you'll be able to create that on the same screen. You don't have to navigate all the way to that particular feature and then configure it, right? So I'm configuring it for allow ping. You can give it any name. This is the place where you'll have to enter a name, any name that you seem it feels to you that this makes more sense. You can do that, and then I'm going to enable the network services, that is ping. So we'll see all this in interface management profile. Again, this is just a day one config, not going into detail. Click on OK and OK. Okay, I'll do a commit as of now. It will come to interface 1/1. I need to see the IP that I have assigned to the router, or I can do from here as well. One second. Configure startup configs. G0/1. 10.1.1, right? Okay. So we'll configure an IP address of 10.1.1.2 on this side. Text 10.1.1.0/24. So this is the subnet that we are going to give on this side. And the IP address on this interface, that is gigabit Ethernet 0/1 on the router, is having an IP address of 10.1.1.1, right? So for this firewall, this will be the default gateway, right? All the traffic heading towards internet will be sent towards this, right? So we'll see how we can do that. Let's go ahead and assign an IP address of 10.1.1, 10.1.1.2 on this 1/1. Okay, this is committed. You can do multiple changes and then do a commit. I was looking for the IP address, so that's the reason I did that commit, uh, just single commit at a time. Okay, so layer 3 virtual router default IPv4. We are going to assign an IP address 10.1.1.2/24, and then click on OK. This is ISP side interface. We don't need to ping. So actually, I'm not assigning any interface management profile. Even in the production environment, it's not a good idea to assign interface management profiles wherein you will be able to allow network services like ping or SSH or all those services on a internet facing interface, right? Because then that gives the bad actors an attack surface to initiate their attacks. Okay, now we discussed that we need zones for this initial day config to work. Let's create two zones. One will be the trust, the other one will be the untrust, right? Trust, and then this zone should be a layer 3 zone because we are going to assign it to a layer 3 interface. And then you can call that interface, that is 1/3 over here. Click on OK. Trust zone created. It's just a we'll talk about zones, right? I don't want to confuse you guys right now. Trust, and then we are going to go ahead and create untrust zone. Untrust, and this zone is going to be layer 3 zone. And then we can add the interface 1/1. Click on OK. This is done. Let's commit the changes for now so that our interface configuration is done. Ethernet 1/3 is connected to the trust zone, and IP address that is assigned is 172.16.1.1. Ethernet 1/1 has an IP address of 10.1.1.2, and the zone that is assigned to this interface is untrust. Okay. So the first step was configuring the management access. The second step is configuring the network interfaces. Okay. Let this commit go through. Almost there. You can close this and you can work on other things. You don't have to wait for that to finish. But the thing that I told you, right? You need to do a commit in order for that to move from candidate configuration to the running configuration. So because this commit is done, you'll be able to see your interfaces. Interface Ethernet 1/1 is up and Ethernet interface 1/3 is up, right? So you can see these virtual router is default. So virtual router is nothing but you can think of a router which is already present inside the firewall, which will be doing your routing for you based on whatever configurations you do, right? So it's virtual. That's why we call it as virtual router. Okay. We'll see more into it, the functioning, how things work. But let's focus on the day one config for now. The security zone that is assigned for Ethernet 1/1 is untrust, and the security zone for Ethernet 1/3 that is assigned is trust. Okay. The zones that we have created is trust and untrust. Now we need to go to the virtual router and add a default route, right? Because we are going to send all the traffic towards internet using Ethernet 1/1 going towards this. Okay. So let's add a default route. In the router settings, first thing that you get, you can see the name of the router. You can see the interfaces which are being assigned to this virtual router right now. We have assigned 1/1, 1/3, both the interfaces in the same default virtual router. You will go to the static routes and click on add. And here we are going to configure our default route. Okay. So the name is default route. The destination is 0.0.0/0. The interface, it's going to go to Ethernet 1/1. The next hop is an IP address, and we need to provide the interface, the next hop IP address, right? So that was 10.1.1.1. Done. That's it. Click on OK. We will revisit this. We will discuss about each and every parameter. I'm repeating myself again because some people might get scared that we are not able to understand. Just go with the flow. We will revisit each and every parameter that is there in virtual routers, static routes, everything. This is just a day one config wherein we are providing the internet access to one of our client machine in the LAN zone. Click on OK, right? So we have configured one static route, and then we need a security policy and a NAT rule so that your traffic will be able to reach the internet, right? So security policy, as I mentioned, we'll configure a very basic security policy, which will say allow everything. We are not doing any security inspection, nothing. Allow any, that is the name. I am going to give source zone is the trust, because from trust the traffic will originate and will head towards untrust. So source zone is going to be my trust, and my destination zone is going to be untrust. And then application is any, service is application default, and then action is allow. I'm not making any changes anywhere. We'll talk about what this log settings, what this log forwarding, security profiles, and all that mean, right? Let's click on OK for now. This is my security policy, allowing everything. We'll talk about this default rules as well, right? Intrazone and interzone. NAT rule, we need a NAT policy so that, so this is just a routing concept, right? Every traffic that is coming to a virtual router should have a NAT so that it can reach out to the internet, right? Same thing we are doing. We are going to configure a NAT rule. I'll name it as default NAT. You can give any name, okay? Source zone, any traffic coming from trust going towards untrust, translate that packet, do the source translation, and do it to DIPP, or we call it as port overloading, right? That's what is the terminology in Cisco, port overloading. That's what we are doing over here, dynamic IPN port, and then select the interface address. Interface Ethernet 1/1 is the interface that we'd like to NAT our traffic to, and then the IP address that is assigned over here. Click on OK. Let's click on commit. Done. Guys, don't worry. We have entire modules to cover the NAT policies, the security policies, the zones, and everything. Just a day one config, okay? But feel free to ask me any questions if you'd like. Let this commit go through, and then we'll test our traffic. Let's assign the IP address to this Windows machine meanwhile. I'll change that to Windows machine. Next time when you guys log in, it will be Windows 7. Okay, don't worry. I'll assign an IP address 172.16.1.2. 2, and the default the subnet mask is 255.0, and then the default gateway is the 172.16.1.1, which is our firewalls Ethernet 1/3 IP address, and DNS as 8.8.8.8, and then you can give alternate is 1.1.1.1. Click on OK, close, close, close this. So this commit is successfully completed. So you can see we are able to reach out to the internet. The Google page is loading on this Windows machine. I'll make sure this is Windows 7. It will be very difficult. This is Windows XP for some reason. I'll modify that Windows machine to Windows 7 so that you are able to access it easily. Okay. So now you can see traffic is going through the firewall to reach out to the internet and then coming back to us, right? And if you see, you will be able to get your traffic logs over here. The traffic originated from the source 172.16.1.2 and heading towards 8888, right? Now, what is this 888? This is your DNS query. You can see the application as DNS base. We have no license over here in this firewall. You are able to identify the applications, right? And then you have SSL, that is the Google page, right? This one is 204.79.197.203. This is your Google's IP address, and this shows as an application SSL because it is going to establish an SSL connection to the server, and then everything will be encrypted inside that SSL tunnel, right? So our traffic is passing through our firewall. We can see that in our traffic log. You can see that the only security rule that I have created is allow any. There's just one security rule that is allowing the same flow going towards C2S and coming back. That is your S2C. You don't need two different rules to allow the same, the traffic which is related to the same conversation. And I have configured a default NAT that is understood, right, how that is going to work. All the traffic coming to your firewall will be NATed to your Ethernet 1/1 IP address, Ethernet 1/1 IP address, and then it will be headed towards the internet, right? So this is your day one config. Things are looking okay. I'll give you, a minute or two before I explain how you can access the lab and all that. If there are any questions related to this day one config, please go ahead. Guys, don't be shy. Feel free to ask any silly questions as well. I mean, I won't mind, and I'm not going to judge you guys, right? Anything at all, be open to it. Okay. Cool. I don't see any questions or any. Okay. Please walk us through the config part. It was pretty quick. Yeah, I'm going to do that. No worries. Default router is 1 and firewall router is 2. Yes, I'll show you that on the serial. Why NAT is required? Poonam, sure, recording will be shared. Okay, I'll check with the. I'll check internally and I'll make sure the recording is available. Why NAT is required? That's a general routing concept. I'll explain that, but not today. Today, my intention was just to complete the day one configuration. We'll get into the details of this, why NAT is required, because that will help you with the return traffic and everything, right? Basic navigation, little bit difficult now. Yes, Salman, in the first time, uh, it will be difficult because everything is new, right? Your eyes are not yet trained to look for the information and they don't know where to navigate, right? It will take some time, but if you do it on a regular basis, it will be like a piece of cake for you, right? So don't worry about it, but it is more simpler. Trust me, with respect to other vendors, This one, PaloAlto has the most simpler GUI. Okay. So let me walk you through again the configuration that we have done. Cool. So the first thing, so I mean, okay, let me give you a brief about. I mean, I was planning to do this tomorrow, but again, I'll cover for you right now. So monitor is where everything related to logs and session and all that information you can come here. As the name says, monitor, right? So you can monitor everything. There will be various logs that you can check and validate and confirm, right? Policies is the tab where all the policies are configured, be it security policy, NAT policy, QoS policy, policy-based forwarding, decryption, application override, everything related to policies is configured in the policies tab. Okay. Objects is related to like address groups, application groups, various other objects, service groups, right? We'll see those will be configured under objects. Network, as the name says, everything related to networking will be placed here in the network tab, wherein you'll have interfaces, zones, virtual wires, VLANs, virtual router, right? All this configured DHCP servers. You can configure everything over here, anything related to the networking part. And then the device is respect to, the device tab will hold all the configuration with respect to the firewall itself, right? Wherein you can take the configuration backup of the firewall, you can reboot the firewall and certificate management, everything that is related to the firewall, will be configured over here in the device tab. Okay. All right. So again, we will go in depth. This is just for a very basic idea. Okay. So the first step that we have done is configure the management access for this firewall. I have spent a good amount of time, I guess, but if you guys have any questions, let me know. So you have like three ways you can configure that using console access, right? Using management interface configuration, then accessing it through the GUI and CLI, or that will be your SSH, right? Now, when the firewall first boots up, for the physical firewalls, you will have a default IP addresses configured, that is 192.168.1.1 for the management interface. In our case, it was a VM. We did not have any IP address configured over there. So we had to manually go ahead and configure the IP address from the console access. This is the console access, right? The way I have done that is by going into the configure mode and then adding the commands, that is set device config, settings, system, IP address 192.168.1.1, netmask 255.255.255.0, enter. And then I have also changed the mode that IP assignment is to be changed to static, wherein again set device config, settings, system, type static, right? So, and once that is done, we have done commit, and then we were able to access our management interface, management access of the firewall, right? Using the GUI. So once this was done, we assigned the IP address of this management PC on the same subnet, that was 192.168.1.2. And then I was able to access the GUI of the firewall from this Windows machine. That is what you are able to see over here. Okay. This was about management access. After that, we need to configure the interfaces, that is Ethernet 1/3 and 1/1. 1/3 is connected to your trust and 1/1 is connected to your ISP network or untrust. We navigated to the network tab, interfaces. We configured 1/3 as layer 3. Let me click on that. So selected Ethernet 1/3. From the drop down, selected layer 3, virtual router, default, which is already present. I don't need to change that. And then security zone, trust, you can either create from here or you can go to the zone and then create from there, right? If I create from here, I don't need to assign the interface. It will be automatically assigned. Okay. So security zone that is selected is trust. Again, as I mentioned, you can create from here itself or you can navigate to zones. Let me show that to you once. So this will open the same page. where we have created, navigated to the zones and clicked on add. So the same page, right? And then you can see it's layer 3 already, because based on the type of the interface, you are adding it here. Then IPv4, which is where we configure the IP address for that interface. This has to be static IP address. IP address assigned is 172.16.1.1/24. You need to click on add. You click add, you enter the IP address, hit enter, and that will be entered. And then we navigate it to advanced, and then management profile, where we have created a management interface profile or interface management profile to allow the ping to this particular interface, right? I clicked on OK. I'll click on cancel right now. I don't want to do that again. Clicked on OK. Then we configured Ethernet 1/1. Similar fashion, the IP address that was assigned was 10.1.1.2. 1 second. And the virtual router is default. Security zone is untrust. The IP address is 10.1.1.2/24. We have not assigned any management profile over here. And the ISP router IP address is 10.1.1.1/24, right? So this is about IP address assignment. Zones, either you can create from the interface itself, or you can come down here, click on add. And if you do it from here, you will need to add this interface over here. Okay, you can select this interface, and then you'll be able to select that interface. Okay, so I created from here trust and untrust. It was a layer 3 zone that I've created because my interfaces are layer 3. Okay. We went to virtual router. We added a default route. We added a default route. This default route is heading. So let me open that 0.0.0.0/0, and interface is Ethernet 1/1, because we are gonna use this Ethernet 1/1 to head out to the internet. And the next hop is IP address. That is the IP address of my ISP router 10.1.1.1. Okay. That's it. We added the static route over here. Network configuration is done for now. We then headed to policies. We created one security rule or security policy, that is allow any. You need to write the name. I provided the source zone as trust, the destination zone as untrust, application as any. I left everything untouched. I have not touched anything over here. Application default. We'll talk about what application default is and what any is. Okay. And then action is allow. Okay. And rest everything is as it is. Okay. This is a very wide open policy that is allowing everything. Then I have configured one NAT rule. That is, I have given it a name of default NAT. You can name it anything you would like. And then original packet, again, source zone is from trust, destination zone heading towards untrust. And then source address translation is DIPP or dynamic IPN port. And I'm using an interface address of Ethernet 1/1 with the IP address of 10.1.1.2 to NAT all my traffic that is going out of the firewall. So we are doing a source address translation. Okay. And then that's it. You can do a commit, and you can go ahead and assign IP address to your Windows machine. We already have that over here, right? And then you can try to access your, once you have assigned the IP address, you'll be able to access the internet. So this is your day one config. Praveen, let's not get into that translation type. Okay, as of now, I mean, that will confuse you, right? It's just see that what is what I'm doing. Just try to replicate that in the lab when you are trying to do that. I'll explain you in detail because we have all the modules listed, right? If you see, uh, we are going to explain the routing techniques, virtual router concepts. We are going to explain what is the security policy, what are different types, interface zones, and we have an entire module for NAT. Where is that? Right? We have an entire module for NAT policies, right? What is source NAT? What is destination NAT? I'll explain everything in detail as of now, because if I start explaining that, it will need a lot of time, right? Missed to show the virtual router Ethernet 1/3 configuration. Okay, I actually did, but no worries. Let me show that to you again. So if you navigate to network, default, if you go to the router settings, these interfaces will be already added because we selected them, selected virtual routers as default when we were configuring those interfaces. So we have not configured anything over here because they were configured during Ethernet 1/3. At that point in time, we selected the virtual router as default, so they will get automatically added over here. And then we added the static routes simply. That's it. Is that okay, Shrikant? Sir, you please go with systematic flow, else it will confuse many guys. Poonam, see, this is the systematic approach, right? This is what is called as day one config. Because if I don't explain the day one config, see, in order for you to understand, you'll have to start somewhere. If I go with explaining, like if I start explaining zones, it will take one day. If I start explaining policy, you will never be able to actually understand the flow of it. So how this is taught is wherein you do the flow first, right? Wherein you understand how your traffic is flowing. Based on that, you'll be able to understand each and every component, right? Because if I see, if I just explain the zones, right, you will not be able to understand what other things are. Okay, that is why today this was just day one config. This is what is the standard procedure. Okay, don't worry, you will get a hang of it. That's what I said in the beginning. Don't get overwhelmed with a lot of information. Just do that in the lab. What I have taught you today, and as the time progresses, as we are progressing through the course, you will be able to understand what the zones are specifically. So we will explain that. We have modules listed, right? We have all the modules listed, and at that time we'll cover that. All right. Admin distance for static one, but here see it's mentioned 10. One second. That is metric. It is not the admin distance, right? So this is the metric 10 and the admin distance is default. So if you see, admin distance is not mentioned anything over here. So it will take whatever is the default and then metric is 10. Could you one second, see Nagarajan, just give me a minute. I'll cover this message and then I'll unmute you. Could you please explain or brief the iOS upgradation basic procedure and best practice? So, Kishore, that's what I'm saying. We'll go one thing at a time, right? We will come to that. The reason I took this day one config is because if I jump directly into the PanOS, you'll not understand how to navigate the GUI itself, right? So, we'll go one thing at a time. So, definitely it is there in the course module. We'll go through the PanOS upgrade procedure. Okay. Uh, in router settings. I'll check that, Vignesh. One second. Why destination address is set as 000/24? That is how you configure the default route. If you go to a routing domain, right? Default address of 0.0.0/0, that means everything that is there out in the internet, whatever traffic is there, will be sent out that interface. That's how you configure the default route. Okay. How metric is calculated? We are not calculating any metric. This is a configurable. You can go ahead and configure it by your. I can configure a second default route with a metric of 20 or 30, right? So we are not doing any metric calculation over here. These are the values. So default value is 10, but you can change that. It is configurable. Cool. All right. Yeah, see, Nagarajan, you can unmute and ask your question. Nagarajan, you there? Uh, what is metric? What is its significance? Okay. So metric again, yeah, Nagarajan. That's okay. I mean, you can speak up. I was waiting for you. Uh, All right. Okay. So metric is again, these are the parameters with respect to the routing, wherein how a route will be preferred uh, when we'll be discussing the virtual routing concepts, where there is a rib and a fib. What is a routing information base and forwarding information base will give you the information which route will be selected as the best route based on which you'll be able to send your traffic, right? So metric will also play a significant role based on which route will be moving to your fib or which route will be selected to send the traffic out of your firewall apart from admin distance, right? Security policy again that was set now. Okay, Shrikant, just give me a minute. Let me answer the questions, then I'll show you the security policy once again. Okay. Automatically unmuted. Sorry. No worries, Nagarajan. If you have any questions, you feel free to ask. No problem. Only default route can be used in firewall. Other routing concepts like static route, OSPF can be. Praveen, it supports a plethora of routing protocol: RIP, OSPF, OSPF v3, BGP, multicast. Right, you can do everything. And then on top of static route, this is a day one config. We are just configuring initial access to your corporate machines. So that's the reason we have just configured a simple static route. We are not doing any dynamic routing as of now. Okay, cool. Uh, could you please let us know how to access the lab? Yes, Gordon, I'm coming to that part as well. All right, let me go ahead and show the security policy again, Shrikant, for you. So you navigate to policy, security, you click on add, right? And it will open a add rule, that is security policy rule for you. You can give it any name, allow any, and then source zone will be trust, destination zone will be untrust, application is any. We are not making any changes on this tab. And then action setting is allow. That's it. Okay. So, and then login session end is checked by default. And then you can click on OK. That will configure your security policy as of now to allow all the traffic. Okay. All right. Let me go ahead and quickly show how you can access the lab. Again, for that, you need to get your user IDs created. For that, you can reach out to Pawanraj. He can let me stop recording, I guess, or let it be there. No, that's okay. For the user IDs to be created, and once your user IDs are created, you will be able to let me. This is committed, right? Let me log out. So either you can access the labs.networkgeek.in directly, or you can navigate to networkgeek.in, and then you have NG Labs over here. This will open a login page for you. Once your credentials are generated, you will be able to log in to your lab. You will have, so you need to enter your username, password, and then you will have two options. One is native console, and the other one is browser console, right? So browser console does not need any applications to be installed on your machine. And native console is gonna, wherein the SSH and the VNC client, these clients that you are able to see would need to be installed on your machine, right? So this is a VNC server or VNC agent, and then you will need a putty to be installed, right? And once you are, if you have that installed, you can use native console or you can use browser console as per your requirement. Okay, you can click on sign in. Let me close this lab. Okay, let me stop these notes first. Okay, close this lab. Once you log in, you will be able to see the folder like PaloAlto firewall training. You will be able to log in. You will be able to see lab one. Click on open. these things will be predefined. As I told you, you don't need to go ahead and configure routers. These are already configured. You need to touch on these part, where in management, out of band management network, where we have a Windows machine, and then your firewall and your LAN segment, right? So this is how you can access your labs. I've already demonstrated the lab for today. And all I, okay, let me stop recording. I think we're good here.